In this video, we're going to talk about solving absolute value equations. So before we can really solve, we have to remember what absolute value really means. So some properties of absolute values, the definition is the distance from zero on a number line. So because we're talking about distance, we're really just talking about a positive value. So we know that an absolute value is always equal to a positive value or number. So for example, if I have the absolute value of 2, it's really just asking me how far away from 0 is 2? Well, it is 1, 2 spaces. So the absolute value of 2 is equal to positive 2. But if I'm asked how far away from 0 is negative 2, it's still just 1, 2 spaces. So we know our absolute value is always equal to this positive number. So if I'm asking you to solve an equation like the absolute value of x equals 3, for example, what I'm really asking you is what number can I take the absolute value of and get 3 as my answer? Well, I know that the number that could go in there is 3 or negative 3, because the absolute value of 3 is 3, but so is the absolute value of negative 3. So we use that information to help us solve absolute value equations. In our first example, we want to know if the absolute value of x minus 4 is equal to 6, well, what could x be? Well, we know, going back to what we talked about before, if I take the absolute value of something, I'm going to just call it a box for the time being, and I get 6 as my answer, I know that the number that could be inside this box could be a positive 6, or that box could be a negative 6. So we use that information to help us with something like this. In this case, I'm taking the absolute value of this entire quantity. So that's really my box, just like that. So again, it's saying that if I want to know what x would be to make this box a 6, I'm really setting up this equation. But I might also want to know what value of x makes this box a negative 6. So I'm really just replacing the box with what's in the absolute value. So now if I solve each of these equations by adding 4 to both sides, we end up with x is equal to 10, or x could be equal to negative 2. So here's how we know that these are both solutions to this equation. If I substitute a 10 back in there for x, I get the absolute value of 6 is equal to 6. Well, that's true. But if I put a negative 2 in there, now it's asking me to say the absolute value of negative 6 is 6. Well, that's also true, because we know the absolute value is a positive distance from 0. So these are the two solutions, the two values for x that would make this a true statement. So let's kind of summarize what we did. First, we have our absolute value isolated, and then we asked ourselves what value of x would make the inside equal to the positive of my answer and the negative of my answer. So let's take a look at another example. In this example, they want to know what the value of x would be to make the absolute value of 3x plus 1 be equal to negative 5. Well, right away, I notice that if I take the absolute value of something and get negative 5 as an answer, that's never possible, because I know that my absolute value is always equal to a positive number. So I get to just stop right here and say no solution, because we know that the absolute value of whatever can never be equal to a negative number. So let's take a look at example 3. So we just said that if I take the absolute value of something and it's equal to a negative, that it can't be a solution. However, in this case, we're not done isolating the absolute value yet. So when you're solving absolute value equations, you always want to isolate the absolute value before you do any two possibilities. So if I get this guy by itself, this term, I can do that by adding 10 to both sides. So now we have the absolute value of 3x plus 1 is equal to 6, which is perfectly acceptable. So this goes back to what we talked about before, where if I have the absolute value of a quantity and it's equal to 6, well, that quantity inside could be a 6 or it could be a negative 6. So in this case, I'm going to set up my two possibilities. My quantity inside, 3x plus 1, could be equal to 6, or 3x plus 1 could be equal to negative 6. I can solve each of these using inverse operations, just like we've done in the past. So we end up with x equals 5/3, or x is equal to negative 7/3. These are the two values that when substituted back into our equation will give me a true statement. So I want you guys to try example 4 on your own. So you're going to pause the video, you're going to do example 4, and then you're going to play the video to check your answers. So you should have gotten that x could give us, or x could be 9 or 5. So again, the first thing I did was isolate my absolute value. That's all of this right here. And then once we get to this step, we're really asking ourselves, what value would make this bubble be 2? So x minus 7 could be 2, or that bubble could be negative 2. So there's one last thing we have to talk about. It's called extraneous solutions. So on occasion, when we're solving equations, we get something called an extraneous solution. It really just means you solve and your answer, when you go back to substitute it and check it, it doesn't actually work due to something we call a domain or a range restriction, which we're not really going to get into, but just know that your answer, although you did it correctly, isn't going to work. So let's take a look at that example. So if I have the absolute value of 2x plus 12 equals 4x. Step 1, we isolate the absolute value, which it is. So step 2, we have our two options. 2x plus 12 could be a positive 4x, or 2x plus 12 could give me a negative 4x. Because I know if I take the absolute value of this part, I'm going to get a positive 4x. So if we solve both of these using inverse operations, we end up with x is equal to 6 for one choice, or we end up with x is equal to negative 2. Well, if I check these, if I actually go back and substitute them into my original equation, they should give me a true statement. So I'm going to replace all of my x's with 6 first. So I get the absolute value of 12 plus 12, which is 24. So the absolute value of 24 is equal to 24. So that one's true. That one works. So I'm going to circle that answer. So far, so good. But now if I go check x equals negative 2, by replacing all of my x's with negative 2, we end up with the absolute value of 8 is equal to negative 8, which is not true because I should get a positive. So because that's false, even though I got the solution by solving, this is not actually a solution to our equation. It's something we call extraneous.